Hi, ladies and gentlemen. We are looking at notes 3.1, which is on something called direct variation. So this is something that you guys have actually done before, but it hasn't been specifically called direct variation. This should be pretty straightforward for you. So let's take a look at question number 1. It says if you leave home and walk in a given direction at a steady pace, your distance d feet from home directly varies. So if it varies directly, that's important. With the time x minutes you walk. You can use a table and graph to represent this proportional relationship. But what does it mean when I say it directly varies? It means that as time goes up, the distance increases at a constant rate. So this right here means that the rate is constant, okay? Sometimes we'll call it a constant rate. Sometimes we'll say it varies directly, okay? But it's the same idea. So if after 1 minute I can go 250 feet, and after 2 minutes I can go 500 feet, then clearly there's a pattern, right? After 0 minutes I didn't go anywhere, right? So clearly there's a pattern. This is increasing by 250 every time. So after 3 minutes, I can go 750 feet. After 4 minutes, I can go 1,000 feet. After 5 minutes, I can go 1,250 feet. Okay, so then question A says fill in the rest of the chart. We already did that. Part B says what is the constant of proportionality? Well, my constant of proportionality is just basically how many feet am I going per minute, right? So that's essentially what this is asking me. So how many feet per minute, right? So we know that every minute I'm increasing by 250 feet. And then if I take 3 minutes and multiply it by 250, I get the 750. So that's my constant of proportionality. So I know that I am going 250 feet per minute. That's my constant of proportionality. And generally you'll see the letter K will be used to represent our constant of proportionality, so that's 250. Okay? And then part C asks us to graph the information in the given chart. So let's go ahead and do that. So when we look at our chart right here, we know that X is time, right? This is my independent variable, and this is my dependent variable. This is my y, okay? So remember, our independent variable always goes on our x-axis. So down here, I'm going to label this as time, and the unit that I'm using for time is minutes. And then on the y-axis, I'm going to label this my distance, and the distance is being measured in feet, okay? So I know that it starts off with 0 minutes, and I'm just going to go up by ones. Depending on the graph, you might want to change your scale, but here I'm just going to go up by ones, okay? And then my distance from home, I can choose what my scale is going to be, but I need to make sure that I get to this 1250. So if I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, going up by hundreds probably won't work. Maybe 200s will work, or I could even go up by 250, right? So I could say this is 250, this is 500, this is 750, 1000, 1250, 1500, 1750, 2000, 2250, and 2500, okay? And I know that after 0 minutes, I went 0 feet. So I can go ahead and graph that out. 0 minutes, I went 0 feet. After 1 minute, I went 250 feet. After 2 minutes, I went 500 feet. 3 minutes, if I look at my chart right here, I know I went 750 feet. Okay, we're getting all these values from our chart. After 4 minutes, I went 1,000 feet. And after 5 minutes, after 5 minutes, I went 1,250 feet. And I know that that pattern is going to continue because it has a constant rate, okay? So since my rate is constant, I'm going to end up with a straight line. So let's go ahead and graph out our line. And this is what our line is going to end up looking like. Right here. It's not the same purple, but that's okay. So this is what our graph will end up looking like, this right here. So this is our information, we're showing that we have a constant rate. This has direct variation. And how do I know that this has direct variation? Because of two things. So let's go ahead and list this out. This is direct variation because number one, it has a constant rate. And number two, it starts at the origin. Now, what's the origin? The origin is always 0, 0. Okay, so it starts at the origin. If it starts anywhere else, it is not direct variation. Okay, so now let's take a look at question D. It says, using rise over run, find the slope of the line. So this piece, we're going to actually spend a lot of time on slope, so we're just going to do an introduction of it right now. So if I take a look at this right here, I know I can go from here all the way up to here. Sorry. Oh my gosh. Sorry about that. And see how much it goes up by. So this right here is increasing from 0 to 2,500. So it went up by 2,500. And then it went over from 0 to 10. So it went over by 10. So my rise right here is 2,500 feet. And my run, it went over by 10. So when I divide that, I get 200, sorry, this is 10 minutes. When I divide that, I get 250 feet per minute. And don't worry about slope. We're going to spend a lot of time practicing how to do slope. Okay? The thing that I want to make sure you guys understand is this right here in this problem, we know that they're going at a rate of 250 feet per minute. So that means that their distance, the distance that you're walking, is equal to 250 feet for every minute. So if I were to write this out as an equation, this graph as an equation, it would be d equals 250t. Okay? Now, in question number 2, it says, think of examples in which you would require rates of change. I want you to think about this on your own, and then I want you to come with a couple examples next time I see you guys in class. So an example that we had here was feet per minute. There are times in real life where you use rates of change all the time. Just make sure it's something per something. Okay, so like feet per minute would work. Anything else that would be something per something, I would take. Okay, all right, so let's take a look at number 3. It says the graphs give information about a penguin's number of heartbeats B over time T. So here this is time, here this is the number of heartbeats B. During normal resting and just before diving, what is the penguin's heart rate? When is the penguin's heart rate greater? During normal resting or just before diving? So this means that I need to know what the constant rate is. How do I know that this has a constant rate? Because I have a straight line. How do I know this is direct variation? Because it starts at the origin and I have a straight line. Well, this graph is telling me that after 2 minutes, the penguin has the penguin's heart has beat 150 times. So how do I figure out my constant rate, or my my constant of proportionality? So what I'm going to do to figure that out is I know that it's 150 beats every 2 minutes. So when I divide that out, I know it's 75 beats per minute. Okay, and in this example here, so we'll call this K1, we'll call this K2. This is telling us that after 2 minutes, the penguin's heart has beat 400 times. So this is telling us that it's 400 beats in 2 minutes. Now, notice for both of these, I always did my, how much it went up by, I always did my Y, and then I divided it by my X. It's always going to be Y right here over X. Okay, so that's key. So right here, my second constant is going to be 200 beats per minute. Okay, so when is the penguin's heart rate greater? Therefore, the penguin's heart rate is greater just before diving, right before it's about to dive. Now, something that's really interesting is if you take a look at the actual steepness of your graphs, it's very clear that this graph is much steeper, so it would make sense that this is the one that has a higher heart rate, okay? I want to write out my equations really quickly for both of these guys, and then we'll be good to go. So this is saying that the penguin's heart is beating 75 beats per minute. So I can say the number of beats is equal to 75 per minute. Right here, T stands for minutes and B stands for heartbeats, okay? And this one is beating 200 beats per minute, so I can say B equals 200 T, okay? All right, for question number 4, we will talk about this next time I see you in class, so you don't have to worry about filling out number 4. We'll do that together, okay? But I do want to talk about direct variation really quickly. So for direct variation, there are a couple notes that we need to write down. The first important note that we need to write down is that it has to have a constant rate. And that's also known as a constant of proportionality, okay? And the letter that we use for it is always going to be K. Constant of proportionality. Okay? And then it also needs to start at the origin. So it always starts at the origin or at 0, 0. Okay? Now, a couple other things that we need to know is that the general equation for direct variation is going to be y equals kx, or we could say y over x equals k. And we'll develop this idea a lot more in depth throughout this unit, okay? Make sure you mark down any questions you might have, and I will see you next time you have class. Have a good day.